Welcome back, everybody. This is going to be part 2 of 3 in my lecture series on solving systems of linear equations. In this video, we're going to learn how to solve systems using elimination. Let's get started. Elimination is just a different tool to solve the same kind of problem. We're still looking to find the solution of systems of linear equations, or pairs of lines in this case. Elimination is a little bit different. Rather than trying to rewrite one variable in terms of the others and then substitute that into the other equation, this time instead, we're going to take advantage of the fact we can manipulate each of our equations first so that we can add them together and eliminate one of the variables entirely. Let me show you what I mean. Elimination is a little bit trickier to get used to, by the way. Step 1 is to multiply one of the equations by a constant on both sides so that one of the variables in both equations has opposite coefficients. Let me show you what I mean with this problem. Notice that if I multiply equation 1 by 4 on both sides, then I'll have a positive 4x in this equation and a negative 4x in the other equation. That's what I'm looking for. So I'm going to multiply equation 1 by 4 on both sides. And then my system will become 4x plus 8y equals 8, and the bottom equation is left alone. Step 2 is to add these equations together. So I take 4x plus 8y equals 8, and I add that equation to negative 4x plus 3y equals 25. And now this is where the magic happens. Notice that by carefully multiplying by 4, I can now eliminate the x's from my equation. And I'm left over with a single variable equation. The next step would be to solve that equation. Luckily, there's only one step for this guy. I just divide both sides by 11, and I get that y is 3. And now, last but not least, I just use this result to find the other variable, just like in my previous problems. So, for example, maybe I'll use our original equation 1, that x plus 2y is equal to 2, or x plus 6 equals 2. That tells me that x should be negative 4. So the solution is negative 4, comma 3. Let's try another one. Let's solve this system using elimination. You'll notice that this one's already set up pretty nicely for us because y in the first equation has the opposite coefficient from the bottom equation. I've got a plus y and a minus y. So step 1 is already done for us. Step 2 is to add these guys together. I'll get 2x, I'll eliminate the y's, equals 2. Check. Step 3 would be to solve that equation for x. I simply just need to divide both sides by 2 to get that x is 1. Check. And then step 4 would be to use that to find y. Using that top equation, I get that x, which I found to be 1, plus y is 1. Subtracting 1 from both sides tells me y is 0. So the solution is 1, 0. One more problem for you. Go ahead and pause the video here to see if you can tackle this one on your own. But if you need a hint, let it play a little longer. Ready for the hint? This one's a little bit confusing because my x's and y's are all over the place. But just like our challenging problem from the last video, I just need to reorganize first. I can move all the x's and y's to one side and all the constant terms to the other side. And now I'm left with this system of equations. There's a second added tricky part though, so if you need another hint, let the video play a little bit longer. Otherwise, pause it and give it a shot. That other tricky part being, well, what do I multiply by? I, for one, see that if I multiply the bottom equation by 3, I'll have a -6 and a +6. However, you could go to eliminate the x's if you wanted. Nothing says you can't necessarily multiply both equations by a number. I can multiply the top by 3 and the bottom by -5, for example, and then I would have a 15x up top and a -15x on bottom and eliminate the x's. But the y's are a little bit easier to do for this problem. Okay, now go ahead and pause the video and see if you can finish it off. The answer that I found was 32/7, comma, -20/7. And this just goes to show you may not always get integer answers. But feel free to pause the video here to check over my work if you need. In this video, we saw how to use the elimination method to solve systems of 2 equations. In the next video, we're going to look at larger systems of equations. Catch y'all in the next one.